Okay, looks like it's about time to get going here. So let's do this. Welcome everybody for the show from 14th of March. I'm Charles, your co-host, and Chris Vaughan here is here to, as usual, to tell you about the looking up in the springtime for 2023. We're going to show you all the good stuff to look for, especially if you're a beginner, and talk about how to use the planisphere. Take it away, Chris.
Thank you, sir. Yes, welcome everybody. I thought that in a lot of places the the schools are out, kids are already starting to be at home. So it might be a good time to do some things that you can note down, take your family outside with you on a clear evening and just look up and start appreciating some of the things in the night sky. So let me just share my stellarium here and we'll get started. There we go. Let's see if this works. Put the little human faces off to the side and go like this. That, here we go. So what I thought I'd do is start out with a kind of an unannotated sky this time around. Usually my screen's all cluttered up with all kinds of labels and things like that, but I thought I just set it up to be a nice, simple sky that everybody would be used to taking a look at when they head outside. So right around this time of year, sunsets around for around 43, 44 degrees north latitude, around 7:20 p.m. is sunset. And by the way, that's that's just today. As every week that goes by now, it's getting later and later at a rapid rate. And then that means that the sky gets totally dark at around 9 o'clock. And what we talk about is the different types of twilight. So we have the civil twilight, the nautical twilight, and the astronomical twilight. And those correspond to times when the sun is between 0 and 6 degrees below the horizon, 6 to 12 degrees below the horizon, and then 12 to 18. Once the sun is more than 18 degrees below the horizon, a while after sunset, then the sky is as dark as it's going to be from the point of view of the sun's contribution. So that full dark sky happens around now at about 9 o'clock. And again, that's also going to get later and later as the weeks pass by. So if you head on out tonight and even the next little while, but tonight in particular, and look west after sunset, the sky is not even fully dark yet, you're going to be captivated by the scene of Venus gleaming brilliantly above the planet Jupiter. Now, a couple of weeks ago, around the 1st of the month, they did a close conjunction where Venus was kissing Jupiter, and Jupiter is being carried downwards towards the sun with the rest of the background stars and constellations because of Earth's motion around the sun. So that change of perspective as we march around the sun once per year causes the sky to turn over week by week, month by month, season by season. And so Jupiter is being carried sunward by about 4 minutes worth every day. And meanwhile, Venus is swinging away from the sun in its orbit, and that caused the two to pass one another, Jupiter to continue to drop and Venus to continue to climb every day. Now, Jupiter's position there in with the twilight around it is our clue that Jupiter is not going to be a great target in binoculars and telescopes for much longer, if not already. So when something's that low in the sky, you're going to get a lot of additional blurriness and distortion caused by the increased blanket of Earth's air that you're viewing the object through. But if you head out tonight, around 8 o'clock, you're going to see the two planets nicely parked in the western part of the sky. And if I sort of advance the date after tonight, so into tomorrow and the next day, you're going to see Jupiter climbing, Jupiter dropping while Venus is climbing up. So about another week or so, we're going to have Jupiter sitting there over the west. It'll get lower every night. And then, another week and a half or two, it'll be gone. It won't really be visible, within the post-sunset twilight. But Venus is going to be around all spring and deep into the early summer. So we'll be able to enjoy it as the so-called evening star for the next little while. So now what's neat about Jupiter, of course, is that if you do put your binoculars on it after the sun is gone, you want to make sure the sun is completely gone before you zoom in on the planets in the west. You can zoom in on Jupiter and you can see if you can capture, you should be able to see its Galilean moons. I don't know why I'm not getting there he goes. There he is. So you can see that actually tonight, if you look out tonight and grab your binoculars, all 4 Galilean moons, so Io, Europa, Ganymede, and Callisto, will all be gathered to the lower side or the western side of the planet. And that happens every now and again, maybe once a week or so. They line up like that, but it's kind of a neat thing to see them all gathered to one side of the planet. Tomorrow night, you'll get a different arrangement. And that's kind of one of the clues that gave Galileo the idea when he observed Jupiter night after night, that those 4 bright dots he was seeing beside the planet might actually be accompanying Jupiter and orbiting around. That's what he eventually came up with. So yeah, tonight you're going to see all those 4 moons sort of parked on the lower part of the planet, but they'll vary night after night. So that's kind of fun to look at. And again, through the telescope, you know, you might be able to see Jupiter's stripes as well, but it'll be swimming quite a bit by this point of the evening when it's that low. Venus, on the other hand, because Venus gets closer to the sun than Earth is, as does the moon, as does Mercury, all 3 of those objects from time to time will display less than full disks. And so Venus right now is in the phase where it's actually waning in phase every night by a little bit. And it's now sitting here at something like 82% illuminated. So even binoculars might give you a sense that the planet isn't round, that there's some kind of distortion to the shape of it. Definitely any backyard telescope will show Venus as being not a round circle at the moment. And as we go in deeper into spring, as I said, Venus is going to get higher every night and even better to look at. But at the same time, it's going to wane in phase. So as I advance the dates here, you can see, I'll just go a little bit later in the evening so you can see it. As I advance the dates later into March and then deep into April, we're going to get to a point where Venus is going to round the outside corner of its orbit around the sun, kind of sit at right angles to the sun's position. And that'll give us a kind of a half moon shaped Venus through our telescope. So that's something to keep your eye out for as we move deeper into the springtime here. So that's kind of a neat aspect. And that's another thing that Galileo discovered way back when he first aimed his spyglass at the planet Venus. And he noted not only did it change its illuminated phase percentage, but it also varied dramatically in its size. And so when Venus is nearer to the Earth than the sun is, it looms bigger in telescopes. And when we're viewing it beyond the sun on the far side of the solar system, it shrinks its disk size quite a bit. So it actually has a very great range in size differences between the two. So you've got your Venus and Jupiter to take a look for. Once we get to 9 p.m., Jupiter's gone. You might be able to spot Uranus. So Venus is actually marching towards Uranus. They're going to have a close encounter in a couple of weeks' time. But you can spot the Pleiades star cluster and the V shape of Taurus the Bull in the evening sky. Then you've kind of got a sense that Uranus will be kind of between the two. And if I zoom in on Uranus, one of the neat things about the planet Uranus, it's actually not that hard to see in binoculars. It's just tricky to know which dot it is and whereabouts to look. But, you can look for, let's see if I can do this, Alt-S, there we go. Should be able to get some star names here. Here we go. You'll be able to pick up some medium bright stars kind of in a grouping here. So there's Sigma Arietis, the constellation of Aries, and Rho Arietis and Pi Arietis. So all these stars are kind of in a similar brightness range, magnitude 5.5, not too far different from what Uranus would have. The difference is that if you look at Uranus in a telescope, you'll notice that Uranus doesn't twinkle quite as much, is a little more of a steady light, and it'll definitely have a bluish greenish tint to it, whereas the other stars would not so much. So again, it's not something that's really easy for beginners to find, but if you want to have a go at it, you can look for it now, or you can wait, in a little while when we get Venus parked near it. That'll give you a better signpost for it. Also in terms of planets up in the sky, we've got our Mars sitting up here above the horns of Taurus. So if I bring up the constellation lines, you can see here the shape of Taurus. The V shape is his face, and we've got the 2 horns kind of sticking straight up towards the zenith at around 9 o'clock in the evening. And Mars last week kind of passed between the 2 horn stars, and it's sort of marching a little bit every night eastward in its orbit. and that's actually going to move it away from the horns of Taurus and kind of towards the feet of Gemini, the twins here. So you can watch for that. One of the neat things to watch for, though, when you're out there looking at Mars, and Mars is going to be observable all night long, all evening long for sure. I think it sets around 3 in the morning. So if you get out after dinner, after sunset, when the sky gets dark, at some point you'll be able to see Mars pop into view. And when you do, you're going to notice as well, it makes a red triangle with the bright star Betelgeuse at the shoulder of Orion and the bright reddish star Aldebaran, which is the eye of Taurus the bull. And that kind of a neat red triangle, all 2 reddish stars and reddish Mars will be up there, in the southwestern sky, about 2/3 of the way up the sky. That's something to watch out for. Mars is actually getting less and less bright and smaller in telescopes as Earth's distance from Mars increases. So we passed Mars on the inside track at the end of November, beginning of December. That's when the 2 planets were closest. And ever since then, Earth has been pulling away, leaving Mars behind. We're traveling faster in our orbit than it is. And so the increase, the distance between the 2 planets has been growing larger and larger every single night. And that means that Mars has been fading in brightness. So it actually, it's already faded that it's fainter than Betelgeuse. And I think around midweek or so, maybe next week, it's going to fade to make it about equal to Aldebaran. So they're not a super bright trio, but they're definitely going to have a red tint. So that's something to watch out for. All right, a couple more things. Now, the other neat thing is that when you're out in the night sky this time of the year, we've got a lot of the, say, top 48 or 50 brightest stars in the sky are visible to you. And if you care to learn some of the brightest stars, then it kind of helps guide your way into astronomy a little bit more and help you navigate through the different constellations and recognize them. Somebody asked me, I think recently, how I identify constellations. And one of the key things is to try to know the bright star and then kind of build the pattern around that bright star when you can see it. So in the evening time in mid-March, we've got the #1 brightest star in the night sky. Obviously, it's the second brightest star after the sun, but Sirius, or the dog star, is the brightest star in Canis Major, the constellation of the big dog. And this star is it's got some really neat, interesting characteristics to watch out for. So #1, it's the brightest star in all the sky worldwide. We're lucky to have it here in our winter sky. It doesn't climb very high for us in Canada, though if you live in a more southerly place, then it'll get a little bit higher for you. But one of the benefits of the fact that it doesn't get that high for us is that we're always viewing it through a little bit more atmosphere. And that means that its twinkling is greatly magnified, greatly accentuated, the twinkling that it does. So when you put that combination of bright star through a lot of atmosphere and that twinkling effect, you get these fantastic, colorful flashes of light. So green, one instant it'll be green, then it'll be red or yellow. You can watch it for a minute or two and pick up these flashes of color as you watch it twinkle. The other neat thing is that because it doesn't get very high in the sky, even around 9 p.m. when it's at its highest point, if you're up later at night, it's getting lower in the west. Maybe you might notice a bright light out the window if you're up for a drink of water or visit the washroom in the night. That could be the star Sirius sort of gleaming one of your windows of your house. Watch out for that. So that's Sirius. Now Sirius is so bright because one of the reasons it's so bright is because it's one of our neighbors in the Milky Way galaxy. All the stars, all the bright stars we see in the sky are all relatively close neighbors to us in our home galaxy of the Milky Way. The Milky Way beyond it, that you can see here in this faint band, those stars are all so far away that it's hard for us to see them as individuals. But the ones that are much, much closer to Earth and our solar system are the ones that we tend to see, making up the constellations in the sky. So Sirius is only 8 3/4 light years away, which means its light has only traveled for 8 3/4 years to get to us. And that means that a star that close, if there was a planet and if there happened to be, intelligent life around a star that close to us, then we could have sort of that two-way communication at the speed of light, speed of radio, on a decades long time frame. So it's, it would be awkward, but it would be doable. So that's kind of exciting to think about something like that. So that's Sirius. Now, what else have we got? So we've also got the star Adhara. So in the constellation of Sirius, once you found Sirius, you want to look lower, and you're going to look for the star Adhara, which is the 22nd brightest star in the sky. Wesen, which is the 36th brightest star in the sky. And Mersenne is down at number 46. So it's almost at the end of our top 50 list here. Now, Sirius is the big dog. The little dog is the constellation of Canis Minor, which is up here. Just put the labels up. And its main star is the star Procyon. Procyon is not as bright as Sirius, but it's up there at number 8th overall. So it's only 7 spots down the list. So that's one you want to look for. And then above that, sort of higher in the sky up. So remember, there's Mars, there's Betelgeuse, there's Aldebaran. Above them, we've got Capella. Capella is a yellowish tinted star, kind of sun-like in its characteristics, up quite high in the sky at this time of the year. Capella is 6th brightest. So already we've got number 1, we've got number 6, we've got number 8. And then in its constellation, Menkalinnan is another one. That one is, let's see, 41st brightness in the sky. Heading down into Orion. Everybody loves Orion and Orion's 3-starred belt. We've got a few bright stars in Orion. We've got obviously Rigel, which is number 7th in brightness. That's his foot. It's a bluish white star. We've got Betelgeuse, as I mentioned, a red star. It's 11th. And the Betelgeuse is actually kind of, jostling for position, because a few years ago, Betelgeuse dramatically dropped in brightness due to a number of factors, which we're still working all the details out. And I think it's recovered, maybe not as fully as it has. So depending on the list you look at, Betelgeuse may be ranking a little bit higher, a little bit lower than 11. And then the belt stars, we've got Alnitak on the east, on the left-hand side. It's number 30th in brightness. We've got Alnilam, the middle star. It's 29th in brightness. And then we've got Mintaka, which on this view in the stellarium doesn't look like it's that much fainter, but it is. It's actually 67th brightest in the sky. At Orion's other shoulder, we've got Bellatrix. Bellatrix is 26th in brightness. And then the other foot opposite Rigel is the star Saiph, which is 53rd in brightness in the sky. So looking at Orion and Sirius, let's see, I think, let's see if I wrote this note down here. Yeah, so which do you think would be the brightest constellation? Which would get the prize for the brightest constellation? So here are the facts. So of the 50 brightest stars, Orion has 5 of them, and Canis Major has 4 of them. But Canis Major has Sirius. So I don't know, Charles, what do you think? Who would you award it to?
Oh, I think I'd give it to Sirius because it's got the brightest star. It happens that in Inuit culture, they call it flickering because on their horizon is extremely low down. So they get all of that turbulence in the atmosphere, and they call it that because if it is flickering, they know that there are winds coming in a couple of days. It's a weather broadcasting star.
That's fantastic. Yeah. All right. So, if anybody wants to put in the chat what they think the award should go to, that's fine too. Sorry, go ahead.
There's a question here, which is, somebody was saying, is the fact that Venus is between the Earth and the Sun the reason it has phases?
Yeah, so the fact is that Venus can be beyond the Sun when it would be more fully illuminated, fully or gibbous. Venus can be at times closer to the Sun, closer to the Earth than the Sun, which would give it a crescent illumination. And the moon is doing the same thing. So when the moon is farther from the Sun than Earth is, we get the fullish phases, the gibbous phases. When the moon is between us and the Sun, we get the crescent phases. So it's the same principle. Cool. All right, couple more. Let's finish up a little bit more on the bright stars. There's a few more to talk about here. Let's see. We talked about Orion. We've also left out Castor and Pollux, which are up here in Gemini. So Castor and Pollux, meant in mythology, meant to be twins, but in the sky, obviously not twins. I mean, you'll see that they're noticeably different. So Pollux is yellowish in color. It's 17th brightness in the sky, whereas Castor is more of a pale white color. and it's ranked at 23rd, so it's quite a bit lower in the list. So you've got those to look at. And Castor, by the way, is a fantastic star to look at in a small telescope because it splits into a beautiful double star. I'm going to mention some double stars again here in a little bit. All right, what's left in the sky that's bright? So that's kind of the winter sky section. There's a couple more around. We've got Murphak, which is a bright one. But as we head into later in the evening, then we're starting to pick up some of the spring constellations. So we're going to pick up Regulus and Leo. Regulus is 21st in the sky. And then late in the evening, by the time we get to say 11 p.m. or so, we get Spica and Virgo. It's down at number 16. So that's a bunch of the bright stars. And we'll come back to kind of mentioning the bright stars when we talk about the starfinders or planispheres at the end of the program. So that, that's something you want to look at. So you want to look at both maybe recognizing the brightest stars in the sky, and you also want to pay attention to their colors. So I did mention at times that some were yellow, some were reddish, some were whitish, and those are all dictated by the star's photospheric temperature, the temperature that it's burning. One more thing I'll mention before we leave is I'm going to swing us around and look north. And this happened to me the other day. It happens to me all the time when I'm doing outreach, especially in my planetarium. People ask about Polaris and assume Polaris is a bright star. And it makes the top 50, but I think it's 44th or 48th in the list. So it barely breaks the top 50. Polaris is not famous because it's bright. Polaris is famous for what it does, which is stay put while the Earth rotates. So all the sky revolves around Polaris. At the present time, Polaris won't always be the pole star, but for this era, for this epoch, it certainly is. Any other questions there, Charles?
No questions, but our observing chair from the RASC, Blake, has reminded me that the outer planets can also show some amount of phase as well, but
Yes.
It's much harder to spot.
But always gibbous. But at varying degrees of gibbous. Yeah,
That's
fantastic.
right.
Nice, Blake. All right, what else we got? So I was also going to say that another thing to look for, and again, these are all things you can just see without binoculars, without a telescope. Just head on out and look up with your friends and family. So you can also notice the common constellation shapes or asterisms. And Charles here is an expert on asterisms, and we're going to have him back to do more about that in the near future. But number one famous asterism that a lot of people, well, let's call it two. Number one would be, say, the Big Dipper, that people are familiar with its shape. So you've got 4 stars forming a bowl or a basin, and then 3 stars in a bent line forming its handle. And at this time of the year, you need to turn around to look into the northeast, and it'll be climbing the northeastern sky during springtime, kind of balanced on the tip of its handle. So it's got bowl up, tip of its handle down. And once you've found the shape of the Big Dipper, you can then look at the bowl and kind of follow the line, as if you're spilling, the milk out of the Dipper's bowl. That's where you're going to find Polaris, find Polaris and Ursa Minor, the Little Dipper, kind of opposite the open side of the Dipper's basin. And in this case, you've got a curved handle the other way and a smaller 4 stars making the bowl. So that's kind of cool. That's that one. But if we swing back around, I think the arguable number two one is Orion's belt, the 3 stars in Orion's belt. And I'll come back to a couple of other neat things about Orion here in a couple minutes. For now, I'm just looking at the naked eye things you can look at. You can also try holding up your finger and seeing if your finger will fit between the stars of Orion's belt. I think it fits. I measured this up. Yeah, each star in Orion's belt is about a degree, a little bit more than a degree. So that's kind of similar to the width of your finger. So if you put your arm at arm's length, close one eye, you should be able to slot a finger in between the 3 stars that way. That's kind of a fun thing to do. What else have we got? I think those are the main ones. Some people say that when the sky is a little bit light polluted or a little bit less pristine, the stars that make up Canis Major turn into a meat cleaver. I haven't actually looked at the the meat cleaver shape there, so I'm not that familiar with it, but I definitely see the dog on a clear night and from a dark place. You can certainly make out the shape of the dog for sure. All right, now how about a couple of things that you can see in the terms of deep sky objects just with your unaided eyes? There aren't a lot, but certainly there are some you can do, and you can claim to be an astronomer even without any equipment whatsoever. So number one, I've already mentioned that one. That's the Pleiades cluster. So up here, if you can find the V shape of Taurus, and remember that's Mars, Betelgeuse, Aldebaran. And then to the lower right, you can look for this bright little clump of stars known as the Pleiades, or the Seven Sisters, or Matariki, or Subaru in Japan. And again, this is an object that looks very busy in binoculars. It doesn't even fit inside most telescopes' fields of view. But if you look at this object in dusk, when the sky's not fully dark, then you can really see the Seven Sisters effect. It's a little bit harder to make out the seven when the sky is dark and there's so many additional stars around. But these Seven Sisters are in the sky together. They're actually dancing or sitting near their parents, the stars Atlas and Pleione, which are the stars at the upper left corner of this clumping. So that's that deep sky object you can see with your unaided eyes. You won't see that beautiful blue glow around it. I think this beautiful blue glow is one of the things that captivated me as a youngster and got me into astronomy, seeing a picture of the Pleiades. I don't know if blue was my favorite color or what it was, but you need to see that. You need a long exposure photograph or a very big telescope on a very dark sky in order to see the blue reflection nebulosity around those stars. So that's number one. That's Messier number 45 on Charles Messier's list of 110 not comet deep sky objects. That's a story for another day. The other one is, I already alluded to it, deep sky object is the shape of Taurus's face. This triangular face of Taurus is actually a star cluster. Let's see if I can get rid of the star names for a second and get rid of the, see if I can get rid of the lines. So if you can see the shape of that open cluster, it's kind of a V. The bright star Aldebaran is actually a foreground star, so it's not particularly part of the cluster, but this is an open star cluster. The stars were all formed together at some point in the past. They're still traveling as a cohort together, and they haven't yet, dispersed or spread apart too much. And the reason that they're so large in the sky is because they're relatively close to us. So they're close to our solar system. Pleiades is a similar idea. It's a relatively close open cluster to us. And one of the neat things about this is to grab your binoculars and start taking a look at some of the double stars that are in this grouping. So let's just bring up the star names again here so we can see that. I think it's Alt S. There we go. So if you bring up that, and I'll bring that shape up again so we can see that. Cool. So I'm going to just highlight a few of the double stars that you can look at. Once you're done enjoying the Pleiades, you can pop on back on over to the Hyades, it's called. And you can look for Aldebaran, and then near Aldebaran, there's a nice widely separated pair of stars called Sigma 1 and Sigma 2. That's a neat little pair to look at. Sort of in the cheek of the bull, we've got this little grouping of Theta 1 and Theta 2, or Hyadum in Stellarium, but it's actually the stars Theta 1 and Theta 2. We've used the numbers 1 and number 2 to indicate, the primary and secondary of a pair, the companions. I've also got a couple close together stars, 80 and 81 in the same area. Then over on the other side, we've got, let's see, the delta stars. So you've got delta 1 and 2 in the area here. So there's delta 1 and delta 2. We've also got delta 3 if you want to make a trio out of it. And then I had mentioned the sigma stars. Where's my sigma stars? Yeah, those were up here. And then these Alkeban stars are another grouping. So there's all kinds of little groupings that you can enjoy with your binoculars around the Hyades. Now, the other neat thing you can do with your binoculars is just sweep the winter Milky Way. I'm just going to make the sky darker so you can see the Milky Way where it is a little better. Just turn off the daylight here. So the Milky Way actually comes up near Sirius. So from the southern horizon around 9 o'clock, if we put south at the bottom here, comes up. It's a little bit stronger in the south, but of course it's going to be weakened and attenuated by the extra Earth's atmosphere that's so low on the horizon. But if you can follow it up, it comes up past Sirius, runs up between Orion and Gemini. Mars is sitting in it as well, and it's going to arc sort of not quite overhead, but a little bit lower in the sky, get a little bit darker between Auriga and Cassiopeia, and that darkness is a lot to do with dust that's obscuring the light of those stars. And then it's going to descend into the northwest through Perseus and the W of Cassiopeia. That's another good asterism to get familiar with, is the W of Cassiopeia, and then sink down towards Deneb. So we're just losing the tail star of Cygnus as it's dropping out of sight here at 9 o'clock. So that's something you want to check out with your binoculars. Now back to Orion here for a second. So if I zoom in on Orion with my binoculars, I'm going to look at an S shape. So if you look between Alnilam and Mintaka, you can see there's a sort of a little asterism that forms a dotted, tall, skinny S shape. And if you squint your eyes a little bit, you can even make it out in the stellarium. I'm just sort of tracing it out with my mouse, but that's a fun one to look at. Also in here, we've got Orion's sword. So I'm just going to turn off the star labels for a second. See if I can make those disappear and give you a sense of how it would look in the sky. So if you're just sort of looking at the region of Orion, you're going to locate the belt, and then you're going to look for 3 or so blobs of light dangling down from the belt. That's his sword. And even your unaided eyes will notice that there's 3 blobs of light, and that you might even tell that the middle blob is a little bit fuzzier than the other 2. And if you put your binoculars on it, then that's where you're going to start to see that the middle blob of light is an extended sort of fuzzy patch, and that's the Orion Nebula part of the constellation of Orion. Let me just bring up some of the star names here again. Annotations, here we go. So the 3 patches of light include Orion Nebula, and then above that we have something called the Coal Cluster grouping of stars above, and then below that we've got a grouping of stars called the Lost Jewel of Orion, which groups around this bright star Hatzia or Iota Orionis. So it's a really great constellation to just explore with your binoculars. You know, once you're done with your naked eye, just grab your binoculars. Last up in the binoculars viewing, I thought we'd swing her back around to the north again. So let me just dial us around over here and pick up the northwestern sky. Remember, there's that W of Cassiopeia. So if you're looking northwest, find the sort of upright sideways W of Cassiopeia, follow it up, and there's a little faint patch of sky here that's not a very bright constellation called Camelopardalis. And you can use the bright star Murphak, so the W of Cassiopeia and the bright star Murphak, to guide you into this area. I'm just going to bring up the binoculars circle here so you can see a sense of scale what I'm talking about. That's about 6 degrees. So if you put your binoculars with the star Segin at the bottom of the field, and then jump a binoculars field like that, and then do it again, and zoom in on this piece of the sky, you're going to pick up what's called Kemble's Cascade. And I'm not going to talk too much about Kemble's Cascade because I think Charles is going to talk about Kemble's Cascade in 2 weeks.
I will.
But it's a really fascinating, unexpectedly looking chain of stars that's in Camelopardalis. So that's something you can hunt down and see with your binoculars. And again, tune in next time and Charles will give us a lot more about that. All right, I'll pause for a second and see if anybody had any comments, questions so far.
We do have one. James is asking, is the brightness or magnitude that which defines the primary star in a double or multiple star system, i.e. primary is the brightest star?
Generally, yes. Blake might want to comment on that because he's a double star aficionado, but I think the general consensus is that the one is the primary. So you can check the comments to see if he says anything about that.
And that's all the questions we have at the moment.
All right. Okay. So
Oh,
let's.
and he's just answered. Usually the brightest star is the primary. Yes, thank you, Blake.
Good. Of course, a lot of times, rules get broken because things change over time. I mean, stars vary in brightness. Maybe when the designation was made, the star was at the peak of its cycle, and then it faded in a while later, and then it ended up not being the brightest star. We have examples of that all the time in the sky, where the alpha of a constellation is not truly the brightest star in that constellation for various reasons. Sometimes it's just an error and it just gets kept. All right, let's wrap up a little bit more now with some sort of small telescope, what you can do with a small telescope. I'll just turn off my binoculars view here. In fact, maybe what I'll do is I'll turn this to a telescope view, about 1.5 degrees, kind of a low power telescope patch of sky. So you can see the difference between the patch of sky that a telescope sees versus that binoculars one that I had a minute. So what I would recommend for binoculars is swing on over to the western sky. And it's not the best time, but if you want to give it a go, and it's actually kind of low, is if you find that constellation of Cassiopeia, the W, the lower half of the constellation at this time of the year makes an arrow that points to the lower left. And if you kind of use your binoculars and kind of go down in that direction, you might see the Andromeda galaxy. So it's rather big, rather faint, especially when it's that low in the sky, but it's something you could try to pick up. I wasn't necessarily going to mention it, but since we're kind of looking right at it, I thought I might as well mention it. So it's getting lower every night, so it's not something that's really going to be a good target for the next after this week or so, but that's something you could look at. But what you can look at is if you find that W shape and head from there towards Murphak, about halfway between the two, there's a nice little patch of sky that you can even see with your unaided eyes if you live in a dark place. And that's this twin clump of stars known as the double cluster. I'll just bring up the designations. You can see them in here. So we have NGC 869 and NGC 884. And what's neat is that you are going to need a low power telescope to fit them both, in which case they'll be spectacular. They both fit nicely in binoculars as well. They're quite far apart. So there's actually, if you measure the distance here, you know, they span about a finger's width of the sky. So you can actually kind of see that patch of sky if you put your arm out, your finger up. And when you're looking at them, you want to pay attention to the difference between them. So one of the clusters is more concentrated. The other one is a bit more sparse. They kind of have a different size as a result. So that's kind of a neat one to check out. I already mentioned Orion's belt. So I mean, Orion's sword. So, you know, if you've got a telescope, in addition to binoculars or instead of binoculars, you know, go on ahead and aim your telescope at the Orion Nebula. You'll be delighted. It won't be in color though. That's the thing about small telescopes, is that to get these color images, we need long exposure photographs that collect all the photons that are needed to build the image. Our eyes just don't have the color receptors in our eyes, just are not getting enough photons from these deep sky objects to produce a color, you know, color visual image for us. But in your telescope, it'll be a black and white image, and it's beautiful on a clear night. You'll see ghostly veils of lighter and darker grays. You'll have dark sort of lanes cutting across, and it's really a spectacular object. And then in the heart of it is a grouping of stars, and in Stellarium, my suggestion would be just to go down here in the menu and turn off the photograph. And this would be, you know, if you can kind of ignore the nebula and just focus on the stars, you'll see is we get a little clump of stars called the trapezium cluster. And this little group of stars is quite obvious in any size of a telescope in the heart of the Orion Nebula. And if your telescope's a better quality, maybe a bit bigger, and the sky is dark and the air is very steady, you might even pick up a couple of extra stars in and around these two. So you might get 6 or 7 even on good conditions. I've certainly seen 6. But that's the trapezium cluster. Again, these are stars being born in the heart of that nebula. So it's kind of a really neat sort of picture of the universe in action, what's really going on. Okay, here's another one. Let's see if I'm just gonna kind of trick us all by kind of turning off everything. And I just wanted to see if we can make this work. So if you're out on a clear night and you've spotted, Orion, see if you can notice to the upper left of Orion, sort of looking at Betelgeuse and the little dog star Procyon. In between those two, I don't know if you can see here, there's a faint bright patch in the heart of the Milky Way galaxy. And that's certainly something you can see in binoculars. You might even see it naked eye. That's called the Rosette Nebula. And we're going to come back to that at the end of the program. But that's a neat object to take a look at with your binoculars. And it's not a hard deep sky object to see. Another one is near the feet of Gemini, up to sort of the area where Mars is heading towards. You can see there's a little lighter patch here above these stars that form the feet of Orion. And that is actually a pair of open star clusters, one bigger, closer one, and one smaller, more compact one, fainter one. And these are named Messier 35, or the shoe buckle cluster, and NGC 2158. So those are, the 2158 is going to be a little bit of a challenge if you're not kind of used to observing. It's a little harder to see it, but the shoe buckle cluster is a nice bright cluster, open cluster that anybody should be able to spot with their binoculars on a dark night. Now for a bit more of a challenge, a couple more that we can see for a challenge, you can swing on over here. This isn't too much of a challenge, but if you go into, just turn this off again for a second.
Hey,
Going into the, yeah.
Just a minor correction. When you were talking about the shoe buckle cluster being above the feet, you said Orion, you meant Gemini, of course.
I meant Gemini. I'm sorry. Yeah, thanks. That's why we need 2 brains on these Thanks, Charles. Yeah, so if you head on into Auriga, which features the bright star Capella that I mentioned before. There are at least three good clusters you can see in Auriga. These are Messier objects again. And I don't know if you can see here, if I zoom in a little bit, there's a patch here, a patch here, and a patch here. And if I bring up the markings for those, that's Messier 37, Messier 38, 36, and Messier 38. And actually, these all have kind of whimsical nicknames. I've got Stellarium set to show just the numbers, but if I turn this off, you can see it's the January salt and pepper cluster, the pinwheel cluster, and the starfish cluster. That makes it, and there's your shoe buckle over there near Gemini. So it's kind of fun to look at as well. Okay, so those are relatively easy. Another relatively easy one is take a look at Orion's head. So we've already talked about his belt, the S shape, the sword. If you look at Orion's head, which is kind of a misty or faintish, brightish patch between his shoulder blades, and put your binoculars or telescope on, you're going to see a really nice clumping of stars, mainly dominated by his main star Lambda Orionis or Meissa. And then there's a star Hecla, which is a little bit fainter, so 3.5 magnitude, 4.3 magnitude. And then Sigma 2 Orionis is magnitude 4. And what's neat is that in a telescope, there's a neat little chain, a little row of 3 stars kind of connecting the dots here, almost like a dotted line. So this is a neat little grouping to look at in a telescope. If you're more of an advanced observer, where you're in the neighborhood, you can check out the Kissing Crescents Nebula. I think that was one of our finest NGCs from a few sessions ago. If you take an image of Orion's head, let's see if I can make this, if you can see the big, extensive pink patch that's showing up here. So that's a big glowing hydrogen region, hydrogen 2 region. It's kind of circling Orion's head. And that's another one you could look for in an image, not in your binoculars. Okay, last up, another neat one in Orion is below Orion's belt, there's a noticeable little bright star you can see with your unaided eyes, and you can certainly see it in binoculars. You put your telescope on this star, it's called Sigma Orionis. And this is a really pretty little grouping. It's almost like a long dart. So like with two stars that are wider, a couple narrow up, a couple more pairing up. And it's a really pretty sight in a backyard telescope, Sigma Orionis, which is just below Alnitak, the eastern star of the belt. Okay, I'm going to challenge you with a couple final ones. And those are going to need me to go around to back to the Dipper again. So I can swing back around, look north, east. Because the Dipper is getting higher through the night and climbing a bit higher every day, the Dipper is actually home to a lot of really nice galaxies. There are a couple down here by the handle that I'll save for another day because they're still a little bit low for galaxies. But if you find the bowl of the Dipper, and if you draw an imaginary line from Thecta through Dubhe, and then kind of double that line in that same direction, you'll come to, if you put your finder scope or your telescope at that double distance, you should be able to see a couple of relatively bright galaxies. Again, another couple of Messier objects. So you have M81, Messier 81, and Messier 82. So it's Bode's galaxy and the Cigar galaxy. They fit together in the same field of view of your telescope. So if you're seeing one, hunt around a little bit. The other one's probably maybe just out of the field of view, but you should be able to get them both in view at the same time. That's a relatively easy for anybody to spot. And these are so bright that they'll work in your backyard telescope, even on the driveway, in the suburbs. You don't need to be in a rural site to see those. They're relatively bright. I think that's all. That I'm just going to stop it there unless there are any questions. I think that's a lot for folks to go after.
Not any questions at the moment, but I had a comment. That head of Orion there, where you were showing us Mesa and the line of 3 stars, that's got a very old name. It's called Aunt Margaret's Mirror. Mesa is the mirror, and the handle is the 3 stars, and it relates to a story by Sir Walter Scott from 1828.
Very nice. Very nice. Nice. Cool. Yeah. So, if you want even more of a challenge, I think this is plenty for everyone to get out and look at. But, if you've got your latest issue of Sky News magazine, it's got an article that I wrote about the Markarian's chain, which is coming up over in the eastern sky later in the evening. So we can save that for another day. So I just thought I'd summarize by highlighting a couple of events that are going to come up through the rest of the springtime, things to keep an eye out for. So we talked about, what Venus has been up to. Let me just take off. I'm just going to take off this marker here. Get rid of that for a second. I'll put it back to a binocular size marker just to make it a little bit easier to give everybody a sense of scale. All right, so first one I have noted is that on March 23rd and 24th, got a really nice, sort of give us the evening sky here, really nice photo op of Jupiter, the crescent moon, and Venus gathered together in the western sky on the 23rd. And because the moon is hopping eastward every night, on the following evening, you get a second go. So if you miss it on the first night, go back the second night. The only difference will be the moon will be above Venus instead of below Venus. That's a neat one. And then I've got another one coming up on the 27th. Let's see what's on the 27th. This one we're going to need the sky to be you need an unobstructed horizon to the west. So I'm just going to give us a 0 here. There we go. And that's where we're going to have Jupiter and Mercury embedded in twilight, but you might, if you're lucky, again, wait till the sun is completely gone before hunting with binoculars or a telescope. But Jupiter is going to pass Mercury. So again, it's the same sort of thing that happened with Venus and Jupiter. Venus was rising past Jupiter while Jupiter's descending. Now Mercury's rising past Jupiter as Jupiter's descending. So for a few nights, they'll be together in a telescope centered on the 27th. Then talking about Venus, Let's get back into the evening darker sky. So Venus is actually marching towards Uranus, and on the 30th or so, Venus and Uranus will be beside one another in the sky. I think they might fit together in a telescope. Yep, they'll fit together in a telescope, but bear in mind that Venus will vastly overwhelm dimmer Uranus. So, you know, you might have to hide Venus just outside the field of view to see Uranus better, but they'll fit together for a night or so. Then staying on Venus here as it marches east into April, there's another nice photo op or nice observing opportunities to see Venus paired up with the Pleiades cluster on around April 10th or 11th. And then at the same night on 11th, that's going to be Mercury, one of Mercury's peak visibility opportunities for us. So that'll be a great night to put on your calendar to go out and look at Mercury on the nights surrounding April 11th. So 10, 11, 12, sort of that range. And then if we switch to the morning sky, a couple more here, just so we get deeper into the spring. I'm just going to go east and set this up to say 7 a.m. or so. Then on May 17th, I've got, I'll just jump ahead here. Here we go, May 17th. Wind this back. We've got a nice, so Jupiter's going to pass the sun, I think in April 11th or so, and then join the morning sky. And on the 17th of May, they'll pair up with Jupiter and the old crescent moon before sunrise. And then there'll be actually an occultation. So I've got here that, Charles, where you are on the West Coast, that I think you might have an opportunity to see the moon occult Jupiter later in the morning.
Yeah, if we got a sky, that'll be a possibility.
Yeah, so basically if I do this, I advance the time, kind of zoom in. Let's see if, oh, that's going to be here in Toronto too, but I think your sky will be a little bit darker maybe where they are.
I think
It's going to be, you need a go-to. You won't be able to easily find either of them without help, but once you've got them, again, keep taking care to avoid the sun. That'll be a neat event to watch Jupiter disappear for about an hour or so and then reappear. So mark your calendars for May 17th here in Canada. And then last up that I had for the list is back into the evening sky. So let's go into the evening sky here and let's go into the west. I've got Mars is going to, in June, and here's Venus too, so you sort of have a 2-for-1, but Mars is going to cross directly through the Beehive cluster, Messier 44 in Cancer on the, for a couple of nights there, June 1st, 2nd, and then it's clear, but 1st and 2nd, so those are a couple of neat ones to keep an eye out for. So mark your calendars. All right, let's go back to now. Any questions, comments on any of that?
Not at the moment. Oh, hang on. That says an inclinometer is a great tool for daytime observing of planets and a thin crescent moon. Just be careful of the sun, as Chris mentioned.
Yeah.
Thank you, Jane.
Very good. All right, so I thought we'd spend a few minutes before we dip into our finest NGC objects for the week, talking about making a starfinder or a star wheel. So I don't know with my background if you can see. This is a Rask starfinder. It's also called a planisphere, a star wheel. There are various names for it. And what they are is they're little devices that let you dial them up to see what stars should be in your sky at a given, given date and time. And they can be paper, they can be plastic. I've even got I've got a fancy plastic one that I bought. This is actually one that's I bought when I was in Australia. So it's for the southern sky. So that's kind of a cool one. And then I've got a fancier one here that was a giveaway for a trade show. That's a
Hey,
planetarium.
Chris, why don't you stop sharing Stellarium? Your picture would be a little bigger and they'd see them a little. There we go.
Let's do that again. Yeah, there we go. So there's the star wheel. That's the Rask version. There's the, oops, there's the Australian plasticized one. And then this is the another one as well. And I don't know if you can see on here, you can, that one more time. So the way these work is there's a wheel, and the wheel contains a properly projected image of the night sky. And they're actually produced for a particular latitude on the Earth. So as I said, to see the southern sky, you needed to buy one. It was made for Australia. This is made for 45 degrees north latitude, which is typical for Canadian observers. Like what? Okay, I'll turn up the virtual background. Here we go. There. Got it. And you can buy them from various vendors, but you can also get your own. You can also make your own, and that's where RASC comes in. So let me open up the RASC Starfinder page. I will share my screen again, so you can see where you can get some instructions to make some. So Charles can put the link in the chat if you may, but under rasc.ca/starfinder, this is where you can find out information about how to use them. And if you scroll down, you can see here there's an option to get a printable monochrome starfinder. So if you click on that, you've got the instructions. And if you scroll on down, you can see it's available in English and in French. I'll click on the English here for a second. This is a PDF file that you can print out. So it's 2 8.5 by 11 pages. You print them on your printer. If you've got heavy paper to print them on, all the better. If you don't, you could even print them on light paper and glue them onto a heavier backing. And so you've got the star wheel, and the star wheel contains, as I said, a representation of the bright stars, the major constellations that you can see in the sky. The RASC one includes some selected deep sky objects. So I don't know if you can see here, but I've got the Orion Nebula, I've got the double cluster, I've got Andromeda Galaxy, things like that. And because the stars reoccur on the same dates and times every year, then these last forever. The only thing is that we can't plot on them the planets and the moon because those operate on a different schedule. So instead, what we do is we've produced a ring. You can see this heavy ring that's plotted on the map, and that is labeled the path of planets. It's basically the plane of our solar system expressed on the sky, so that if you see a bright object on or near this ring on your planisphere that isn't already identified on the planisphere as a bright star, then it must be a planet. And then the other part of this is a holder that you print, cut out, take out this center oval. So you're going to be actually looking through this window at a section of the star wheel behind it. And the way it works, I'll just stop my screen here, is you're going to insert the star wheel into the holder. Then you're going to find out what date it is and what time it is. In this case, I can dial this around to say I take 9 p.m., which is over here. And I can dial this around, put mid-March, March 14th. And then if I pinch it, hold it tight, then this oval should show a representation of the sky overhead. The stars that are near the labeled horizons, so the zenith would be roughly the middle of the oval, and the stars between the zenith and the horizon should be in front of you if you turn and face the southern sky. If you want to look in a different direction, then you continue to pinch it in place, and you just rotate it into whatever direction you happen to be facing, and the stars for that part of the sky will appear above the horizon word on the page. So it's really handy. Now, a couple of things to watch out for is that they're designed for a particular latitude, and you may not live at that latitude, so there'll be a little bit of adjusting, a little bit of difference. And also, these don't account for daylight savings unless you factor for that when you're setting the time. So you may find it's a little bit different during the summer months, if the clocks have changed, but that's fine. You can just account for it by adjusting accordingly. Now, if you want to make your own, so I'll share my screen again, and I'll go back to a couple other neat links. So that's the Rask one, which is a great resource. You can also make your own, and just open this hyperlink up. There we go. So this is astronomyinyourhands.com. And if you go to this one, you can actually type in a country and a city, or if you want to, you could put in, let's say, 8 degrees west, 45 degrees north, 4 hours ahead of UT for the summer months, and set that. Then you could ask for tabloid or letter. Click that, and then you click on the appropriate link here. So the pocket, the city wheel. So the city wheel is showing you a fewer number of stars and constellations because it's meant to be a light polluted sky that doesn't have as much detail in it. But if you click on the Milky Way, then you're going to see lots and lots more detail. And the beauty of this system is that it's valid for wherever you happen to be viewing from. So you can make a customized version of it for yourself. So, and then Charles, if you put that link to the Lawrence Hall of Science, it's got some neat
it's in there.
Links to a variety of them as well. So that's a planisphere. I'll take any questions on that. Comments?
One person noted that make sure when you put the RESC starfinder in, you include the hyphen. It won't work without. But yeah, no questions. But that is fabulous, being able to get yourself one that is specific to your location. That's something that would be very useful to. And yes, we do give out hundreds per year. Someone's just saying, yeah, hundreds with my center. I'm sure it's the same with all the rest in the RESC.
Yes, no batteries, Blake. Very good. Very good. They work with red headlamps too. Very good. Yeah, no, I did have in my notes as well to mention that, you know, they are great for beginners, but if you are, you know, chasing some very specific targets and, you know, getting really serious about your observing, you know, I would consider then stepping up to an app like Stellaria Mobile or Sky Safari or Star Walk, one of those apps. But the planispheres are fantastic outreach for us for giving out to beginners. All right. Well, no further discussion. I think we could jump into our finest NGC minutes.
Yes, I think we're ready for the finest NGC for this is the 7th episode, I believe.
All right, let me just share my screen again. Here we go. Get that set up. And we're going to go to tonight's sky. So we're actually finishing the winter targets in the finest NGC list on this session. If you want to find the printed version of the finest NGC list of objects, they were compiled by Alan Dyer, Rascal Alan Dyer. They're in the Observer's Handbook on pages 316 to 318 of the current edition. And as I said, we've been running through them, a handful per session, and we're going to get into the last of the winter group right now. So I'm just going to bring up my bookmarks here. And I'm going to actually mention some things we've already touched on earlier, as you'll see here in a second. So where's my March? Here we go. So first up, I've got our friend, the Rosette Nebula. So remember, we were looking south on a clear, dark night. And we actually have a beautiful, dark, moonless week. So this is a great time to get out and pick up these objects, as well as go back to a couple of the previous sessions where maybe there was a bit more moon when we described them, but this would be a great week to tackle all these finest NGC objects. So the first one on my list here is our friend, the Rosette Nebula. Remember, I talked about it being kind of partway from Betelgeuse to Procyon. You can actually draw a line from Betelgeuse, from Bellatrix to Betelgeuse, and kind of double that, and you're in that neighborhood. but this is a winter showpiece. So it's a relatively big, it's spread out and not overly bright, but it's definitely a noticeable object on a dark night. Maybe, probably with your unaided eyes if you're in a rural sky, but definitely in binoculars at any size of a telescope. If you're viewing it, with binoculars, one idea that I saw suggested was try to put a branch or a tree down the middle of the object. And that way you're obscuring the bright star cluster in the middle and being perhaps able then to see the gas halo around a little bit better. So we've got the Rosette Nebula is considered the rose-shaped pink area of glowing gas. And then we've got an interior star cluster called, I think it's NGC 2244 is the interior star cluster. If you bring up the symbols here, you can see them both. So yeah, that's one trick I had never tried, of occulting the bright cluster in the middle to see if I can then better see the rest of it around. You can, so what's neat about this is that the star cluster itself was discovered by William Herschel back on January 24th of 1784. It's his class 7-2. And remember, he was using what he called his 20-foot telescope. So it was a big, wide aperture, I think about a 12-inch aperture telescope. And it had a relatively narrow field of view to it. So he actually never saw the rosette. He only saw the cluster. So the rosette itself is not part of his Herschel list. But the rosette itself, the rosette part was actually discovered kind of in pieces by later astronomers, Marth, Swift, E.E. Barnard. They're all from the 1864 to the 1890s were kind of independently discovering sections of this big nebula. Sir Patrick Moore named this object as numbers 49 and 50 of his Caldwell list. So, it's not on the Messier list, but it is on the Caldwell list. I mentioned where it is. It's near this star, Epsilon Monocerotis. But you should be able to kind of use Bellatrix, Betelgeuse, and Procyon to get yourself into the right area because it's relatively easy to find. You want to use low magnification. So if I kind of put my simulated telescope view on it. So I've been using a 25mm Plössl in a 6-inch Dobsonian reflector, and you can see that the cluster's fine. It's nicely magnified at 35 power, but you're not going to have a nice, difference from the nebula to the background to be able to readily see or recognize the limits of the nebula. So what I recommend is, using the lowest power you've got to do that. So binoculars work great if you've got an eyepiece that's longer, focal length than 26, and give you a wider field of view. That'll do a better job. But, if not, if you're stuck with the higher magnification, then all you really want to do is just, nudge your telescope around and just explore the limits of it with your whatever power you do have. Once you've enjoyed or found the bigger picture, you can start zooming in. You can enjoy and appreciate the internal cluster, look for the colors and types of the stars, do some counting, see how many stars you can see. You want to see if you can notice any structure in the nebula itself. There are some dark pockets, these Bok globules they're called. You can also have some dark dust lanes, giving it some internal structure, so that's something to look for. You can use an O3 filter or an ultra high contrast filter to preferentially brighten up the H2 section. And again, you're going to see a nice bright prominent field star 12 Monocerotis kind of dominating the center, near the center of that cluster as well. This is about 5,000 light years away. It's a really terrific object that, gladly that Alan Dyer is highlighting it, but it really deserved to be famous earlier than this. Next up, we've got something in the neighborhood. So if you're looking in the sky in this Monoceros area, you've got your Rosette Nebula. And if you start moving north towards the the toes of Pollux, you're going to encounter some more deep sky objects, one of which is this beautiful Christmas tree sort of cone cluster patch. But before you get there, you're going to run into, if you're paying attention, a nice little object called Hubble's Variable Nebula. So this is finest NGC number 33. It's NGC 2261. And it's a reflection nebula that was discovered by William Herschel back on December 26th of 1783. It's his class 4-2. And it's also a Caldwell object. It's Caldwell number 46. So it's about midway between the Rosette Nebula and this bright star Alzir, or Zeta Gemini. I think that's Zeta, or is that Chi? That's Chi Gemini. But about midway between the Rosette and that star is where you're going to find Hubble's variable. Now, what you can do though is if you can, it's easier to spot the Christmas tree cluster and nebula. So they'll actually share the field of view of a low power eyepiece. So again, this is a 35 power. So once you've got that, you want to navigate back to the south a little bit to pick up that nebula. You also want it, when you've got it, then you want to crank up the magnification to maybe 150 or 100 just to get to the appreciation of its shape. So it's going to look a bit like a comet shape. There's a brightish star in the air near the southern section, and then a wedge-shaped comet shape to it beyond that. So this one will not be helped by filters because it's a reflection nebula, and oxygen 3 and ultra high contrast filters, they tend to suppress the starlight and look for the emission. And this is actually reflected starlight, so it's not going to really help to put a filter. But you can try it if you want to give it a try. That's no harm. Definitely averted vision will help a lot with this object. So you want to note its shape, its size, how it varies in brightness from place to place, and maybe make a sketch. And it is known to be variable in brightness, so you could actually check back from time to time, and maybe you could pick up some differences in that variability, some differences of brightness. Let me go back to my standard 26 millimeter. You can see how tiny it is. All right, next up, we've got, declutter here a bit. We've got an object called the Gemini Nebula, or the Double Bubble Nebula. It's up here in Gemini. Just double click here and highlight that. It's kind of nestled between the necks of Castor and Pollux. Sometimes it's called the Ant Nebula or the Peanut Nebula. And it's actually rather large, but it's got this really neat complex shape to it. So it's about a magnitude 11.3 or so. So this is a finest NGC number 30, and it's called NGC 2371 and NGC 2372 because William Herschel thought it was two objects, and he gave it two numbers. So he observed it on March 12th, 1785. So a couple of days ago, it was the anniversary. And he gave it class 2 numbers 316 and the other one. So this is actually a planetary nebula. It's one of the biggest planetary nebulas that we know of. It's a bit fainter, so you need a larger telescope to really appreciate it, maybe a 6-inch telescope or an 8-inch or bigger, and nice dark skies. I've got noted that it's located 1.6 degrees north of the trio of stars 64b and Iota. So this clump of stars kind of between the where Castor and Pollux are kind of holding hands, this group of stars. And then you want to look up from there. What I did is I actually put my finder scope, I think is it Alt B or Control B? There we go. I put my my Telrad, making a triangle below Castor and Tau Geminorum, make a nice sort of isosceles triangle, and that should pick it up as well. Turn that off again. Again, this one will be better to search at low power and then start cranking it up once you've got it identified. So there it is at 35x. You can see it's really rather small. And then if we increase the power even double, you're getting into a sweet spot. So, it's in the range of 65 to 100x is probably a good spot to use. The oxygen 3 filter will help. The UHC filter will help. Averted vision will help. You want to make note of it. Any shape you can make out. Can you see the lobes in the two directions? How far can you follow those? can you see a central star? So there's been various reports on whether the central star in this planetary nebula is actually visible or not. I don't remember noting the central star when I looked at it, but that's sort of something to revisit and look at again. See if you can. It's about 5,000 light years away. All right, next up, we have another planetary nebula in Gemini, famous object, and formerly known as the Eskimo Nebula. I'm sort of suggesting that people start referring to this as the Parka Nebula. I've heard some people mention it as the Lion Nebula, although I think there's another object called the Lion Nebula. So I think the Parka is probably appropriate. I'm going to turn off the stars here so you can see the shape of it. It's a nice bright planetary nebula. It's rather small, kind of looks like a face, and surrounded by a furry or fuzzy ring or parka hood. Discovered by William Herschel back on January 17th of 1787. It's his class 4, number 45. It's another Caldwell object, Caldwell number 39. Now this one you can see in any size of a backyard telescope with decent quality optics in it. It's near the star Wasat. So let me just bring up the star names here again. And I think it's alt. Yes, there we go. So we've got Castor and Pollux up here. We've got the arms of Gemini. Then we've got the two wastes of Gemini. And the easterly one is the star Wasat. And you can, if you put on the kind of finder scope or telrad, if you put your telrad rings a little bit to the southeast of Wasat, then you should be in the neighborhood. But it is a small object, so you're going to need to be in the neighborhood before you crank up the magnification. You could try using the oxygen 3 filter. The oxygen 3 filter will brighten up this one speck at the expense of the other star, so that'll give you a clue where to zero in on it. And then once you're there, you can see that it's really tiny at the 35, even at the 64 power. So what you could do is then maybe try going up to, say, 150, or even if the conditions allow for it, you could try putting a Barlow on there and getting it, above 200x, just to see if you can see the shape of it better. Once you're there, you're going to look for the shape, any characteristics that you see. Play with the averted vision effect, see if you can get the blinking planetary effect where the central star is bright, and then it fades in favor of the envelope around it. So that's a fun thing to do. It's about 4,200 light years away. So that's the Parka Nebula. The last up here is I've got the UFO Nebula. The UFO Nebula is up here in Lynx, and it's not in a very bold bright star patch of the sky, so it's a little bit harder to find it, but it's a nice edge-on spiral galaxy. That edge-on orientation provides a bit of a higher apparent brightness for it, so it makes it more accessible in smaller aperture telescopes once you've found it. So definitely 4-inch, 6-inch, maybe an 80 millimeter, I'm not sure, but definitely medium-sized to larger apertures would be good under dark skies. This one was discovered by William Herschel back on February 5th, 1788. It's his class 1 object number 200. And I have it written as on the line connecting Alpha Lynxis. So there's Alpha Lynxis down here to the star Iota Geminorum. So where's Iota Geminorum? It's here. So if you can see those two stars, then that galaxy's right on the line between them. An easier, kind of a more local way to do it is to connect the line from Iota Cancri and go up to 10 Ursa Majoris, which is actually being used to make part of the constellation Lynx. But sort of those two crossing vectors will give you the ballpark of where you need to be. What I did is I started at Alpha Lynxis and I just used fields of view to migrate myself and star hop to the right little spot. Actually, what you can do is if you start at Alpha Lynxis and sort of migrate yourself, west southwest, you can pick up this grouping of medium bright stars, the sigma stars of Cancer here, sigma 1, sigma 2, sigma 3. and then just slew a little bit to the north and pick up the galaxy there. You want to search at low power, but you do want to magnify once you've got it. This is a little bit too much. Let's go back to, there's our original 35x. So 35x, 50x, in that sort of range would be really good. You want to note its shape, its its profile, how it varies from tip to tip and center, and what it looks like in the center. Is it symmetrical? You may notice that it is or isn't, and what its orientation is. And there are some nice field stars in the field of view as well to pick up on. It's about 30 million light years away, so it's a jump farther away. So that's it. That's the last of the winter finest gems. I think there's some real gems in that list, and hope everybody has a good luck getting out and seeing some of those.
It's an excellent list. I've enjoyed going through the objects on that list. The parka is also known as the clown face.
Clown face, yeah, that's another one.
Yeah. And somebody said, how about an eyeball nebula? Don't even get me started. There's a whole lot of eyes up there. We'll have to do a show on that sometime.
Certainly can, certainly can. Yeah, so that's all for today. If no one else has any other, are there more questions, discussion?
Yeah, they say in Stellarium, which symbol selection is the equatorial mount? It's down at the bottom.
So the trick to that is that you've got to configure it first. So this is kind of a two-step process. I don't think it's there automatically. Let's see, but where it is, it's in the horizontal bar. And if you can see here, so you've got your centering tool. So if I go on Procyon, I can center Procyon, and then the equatorial is to the left. That flips it, toggles it on and off. But I'm not sure if that needs to be configured. If you go into the settings, let's see here. If we go into the extras, so you want to make sure. Okay, so it's not one of these buttons. So it must be there natively, but sometimes some of these buttons don't appear unless you go into the extras and switch them on. Great. Anything else?
Yes, the links are in the chat. Take a look. They're all in there right now. So, and we've got scanning down here. It's loaded by default, we're told.
Yeah.
By Frank Tamaris. Bright is on and dim is off. Yes, that was the answer to the other question. Someone said bright is on. Yes, it is. Okay, good job.
Well, I appreciate everybody tuning in today. We'll be back in a couple of weeks. We're going to switch it up a little bit and put Charles in the pilot seat, and I will co-pilot, and he will share some more of his vast knowledge about asterisms.
Thank you.
And we'll see you then. In the meantime, I hope everybody gets some clear skies. I know I want some, and keep looking up.
Well, here's the homework. If you've got an asterism that you haven't told anybody yet, bring it next week, because this is all going to be about Canadian RESC members who have got asterisms up there, and I want you to be on that list if you aren't already. So bring it.
All right, very good.
Thanks, everyone.
Thanks, everyone. See you, Charles.
Thank
Bye
you.
all.